Dzień dobry. Słuchać mnie? So despite my last name and my weird first name and last name, this is actually Armenian. I had a chance to live in Poland and study and work in Poland for 10 years and in beautiful Krakow. And so, you know, when I got a chance to actually come over and present at the Bitspiration, it was in some way a chance for me to have a small return of favor to Poland, where I spent the best years of my life, and to talk about fraud detection, which when we discussed with Andrzej, he said, well, that's a great area, and they will be, first of all, very educational. And also, I think in the context of startups, especially, I know there are some startups which deal with payments and with financial sector. It's very important to have the fraud detection set up from get-go rather than as an afterthought, because otherwise you are going to get hammered by the fraudsters. So, will there be? Should I? Sorry, just a second. Do I use my computer, my own computer, for that? Yeah. Oh, sorry. So I will try to keep it within time limits. Before it starts, I will talk about agenda. So agenda is to first actually go over the field, what we mean by risk management and fraud detection. Sometimes people confuse it with information security, malware, and other stuff. So I will try to draw the distinction. I think the best way of actually describing the area is to show some examples. I've been in the area of fraud detection for the last 12 years, over 12 years, within eBay Inc. And then I was also advising different startups on how to deal with fraud detection. And I've been always fascinated by the field because it's it is a great example of how creative human beings are. And I got it finally. And we'll talk a little bit after introduction about the expert rules, and then we'll talk about when the rules, which are kind of the first line of defense, are not really enough when you actually overgrow them, and then you switch to using machine learning and analytics models. As you guys know, it's like one of the hottest subjects right now to actually predict fraud. And then I'll dwell a little more into how the models work and how they work, the synergy between models and the rules, and at the end there will be some final notes. But first let's talk about what is really the fraud detection. And if I were to summarize it within a sentence, it's like using the legitimate feature of a product to commit fraud. So it's not about breaking the product, it's not about infecting the product or the service, it's about actually using whatever is designed for honest usage, abusing it to commit crime. And I have a couple of examples, some again going back to the creativity of the bad guys, showing how the bad guys think, and I sometimes draw inspiration from them. So in US, and I believe probably also in Poland, there is a very popular product which is called gift card. So you can go and buy gift card if you, for example, want to make a present to somebody and don't want to give them cash, but also you don't know exactly what they would like. You know they like this store, so you buy a gift card from that store. So in the first iteration, when they were introduced in US, the gift cards were freely available in a store. People could go and pick them, and without activation, they wouldn't have any value. So they would typically take the gift card, go to the cashier would activate them once they pay, and then after that gift card could be used online in the stores. So there were no PIN codes, nothing scratchable was initially used. So what bad guys figured out how to defraud this scheme, they would go and they would scan the cards. So they would scan the card numbers, which again, before they are activated, they mean nothing, right? But they will scan and store them, and then after it is activated, then they would write a script which would periodically go to the website and check whether this given card was activated or not in the meantime. And if it is activated, then they would use the card number essentially online to actually steal the value, right? It was so severe that the whole industry went back to actually redesign it so that they actually had these scratchable PIN numbers, which actually prevents that from this type of abuse. Now, another example is pretty interesting too, is when you have a website where you want to go and attach your bank account to it. In the United States, for example, it can be PayPal, or it can be any other service when you want to use your bank account. So one typical way of proving that you actually own the bank account is they do the so-called random deposit. So you go to open an account, and then you add your account number, and then what happens is that online business actually puts 1 or 2 random deposits, and these deposits are between 1 cent and $1. And after that, normally the user goes to his or her website, reads the random deposit number, goes back to the online business and puts these 2 numbers or 1 number, thus proving that they actually have access to the bank account, right? So the fraudsters, what they did, they actually go through this process, use the same bank account, and run a script which runs it, let's say, 100,000 times, right? So if you don't have the right way of detecting this kind of behavior, what happens is that the online business puts 100,000 times multiplied by these random numbers to the same bank account, and fraudsters just take money and run, right? So again, this is a real case. It happened with one big corporation, not with PayPal, in the past. Relatively easy to detect, but if you never thought about it, you never thought about it. And then this one is my favorite. It's actually, again, is a legitimate abuse, which happened about a year ago, so it's pretty fresh. So let's say you know somebody's name, email, and physical location. So these 3 pieces of information is relatively easy to get by, right? Now you want to take over that person's Amazon account, and if you live in the US, for example, chances are that that person has an Amazon account. So having name, email, and address as an input, you call Amazon, and you tell them that you want to add new credit card number to your account. You give them your email, you give them your address, and that's enough for you to add a credit card. So because adding a credit card typically is not something which raises red flag, right? So after that, now you have name, email address, and credit card on file for that account. Then you call them again, and you call them and you tell them that you want to add a new email to your account. And this one is already a little more risky, so for them to know that you are the holder of the card, of the account, they ask you to give them credit card on file. Because the credit card you just added, then you give that credit card to them. After that, you have name, email address, new email, and new credit card. Now, having a new email, you go to Amazon.com, and you go through the forgot password flow, and the new password is sent to the email account which you just added. After that, basically, the account is taken over, right? So again, as you can see, it's the ingenuity of the bad guys. Companies such as Amazon, which you can imagine has a pretty big anti-fraud team, still had this loophole very recently. Generally, what is fraud detection, right? So preventing cases like this might be a short answer. Typically, the problem is that you are chasing a moving target. The fraudsters it's a cat and mouse game, and in order to be efficient in that fight, you have to have tools and processes and people in place in a company to counter this type of incoming pressure, as they call it. Whatever tools and processes you have in place, it's obvious that none of them are absolutely perfect. So, of course, there are cases when good guys are being caught in fraud detection or bad guys are being missed. But as I said, it's kind of a cat and mouse game anyways. So what is the first line of defense? Typically, especially if you are starting a startup and you don't have data and you are building a functionality which might be a target. And again, if you are building I don't know, social network or beacon, or you might not be a target. But if you are building, let's say, payment system, then you most probably will be a target. As soon as fraudsters know about you, they will try to abuse it. So where to start? Typically, if you start from lack of data, from scratch, you start from some kind of a logical, expert-driven rules. And typically, the rules are, in medium-sized companies at least, they start leveraging so-called decision services, which are the decision engines, which are kind of specialized pieces of software, and you have some of them are commercial, some of them are open source, where they allow you to build some simple rules and deploy them fast enough that you don't have to redeploy the entire site in order to introduce some type of a new rule. Now, what are the rules, just to be a little more kind of detailed? So this is kind of a simple rule. Of course, these rules can be a little more sophisticated too, but this is if then and action type of logic, right? So the syntax is pretty restrictive, but that also allows you to give the control to, let's say, somebody who deals with fraud and somebody who might not be a programmer. They typically have a pretty intuitive UI through which they can actually introduce this type of rules. Ultimately, there are three pieces kind of which needs to be answered. One is the so-called checkpoint, at which point in the flow, in the site flow or mobile application flow, you want to check. You want to introduce this evaluation, risk evaluation. Second piece is what are the data you can rely on. In this case, for example, the data is the time on file for the user, what is the transaction amount, etc. And the third piece is action. What action you can apply at that checkpoint. Of course, as you can imagine, the data itself can grow. It can be your own data. It can be third-party data. Like a typical example of third-party data is IP intelligence data. For example, IP geolocation or type of IP address. You can have obviously the same information about phones, physical addresses, and so on. And the action typically can be either restrict because you are pretty sure that this is fraudulent activity, or you can queue it and review later on. It all depends on the context. As you grow, as the company grows, you have to add more and more rules. So I was a witness of that process when I worked at eBay or PayPal. When at some point they reached 10,000 rules, for example, in a rule engine. And you can imagine with 10,000 rules, no matter how many people you have managing them, it's kind of it's getting a little bit out of control to actually know how these rules actually interact with each other, because these rules are probably created over time by different people, and there is obviously a need to have some kind of system and some kind of system of evaluating which rules are obsolete, which rules are actually might be counterproductive. The reason for introducing a new rule might be simple. There are new MOs, like modus operandi of fraudsters, like the one with Amazon, for example, or they might be new products, like both eBay and PayPal were shipping new products fairly regularly. And so it opens up for new types of attacks. So obviously you have to still introduce more rules to cover the potential loopholes. There is new data, and there is new ideas. So all in all, you keep adding more and more rules. At some point, again, as I said, it becomes unmanageable. So what comes next is what we call analytical models, and both eBay and PayPal had a bunch of them, and they are essentially predictive models. They are data-driven, they are typically they are very similar to other predictive models you might have heard of, like predictive models about marketing. It can be predictive models about weather forecast. In this case, it's similar. Essentially, at the end of the day, you are trying to predict whether the current transaction or current context is fraudulent, potentially fraudulent or not at the point of that transaction, right? Now, I put here a small, a pretty simple kind of comparison table, where you can see that models are relying on many more variables than the rules. They have heavier life cycle. They're kind of strategic weapon in that respect compared to rules. They scale better, and what is very important, models produce one single so-called score, and that score is a probability from the model perspective, probability of the given transaction being fraudulent or not. And because you have one number, then it's much easier for you to kind of move your, depending on your appetite on risk, decide what would be your action, right? So for example, and I think I'm talking about it later, but if you have, let's say, score between 0 and 999, you can decide that, the higher, the more riskier. You can decide that up to 500 you are going to let them pass. Between 501 and 700 you are going to queue them, and over 700 you are going to decline them, for example, right? So this is another illustration of the difference between models and rules. So let's say this is the red dots are the bad transactions, blue dots are good transactions. So what analytical model allows you to do is essentially like a syringe, like pushes into a site the population which has a much bigger concentration of bad transactions. Again, it's never black and white. It's never like you still have some blues there and you have still some reds on the right side. But and that's the performance of the analytical model. The better the model is, the fewer blue dots you have on the left side, right? And compared to that, for example, rules are much more kind of tactical and localized. They are targeting one particular behavior. And it can be, when I say particular behavior, it can be as simple as, oh, we see this trend with new automated email addresses created, from this IP address, and this is the pattern they're following, and this is what they're doing. Okay, let's quickly write a rule and push it live to shut down this particular pattern, right? Obviously, again, it's not scaling. I can talk a little bit about the model stack. So at the bottom, obviously, you have a lot of data, right? And that data keeps growing. It's your historical data, it's third-party data, it's data, the feedback from the agents. Obviously, it's a context data. By context data, I mean the context which you are evaluating. So for example, if you are evaluating transaction, this is amount of transaction, this is who sends money to whom, for what. So from data, you essentially build a population of so-called features. And there is a process which is called feature extraction. And essentially, you can look at it as taking this whole raw data and extracting some variables which can be potentially predictive of the behavior. And I'll give an example on the next slide of what is the feature. And then on the top of the feature, you build the model. So model takes the feature as an input, and let's say, here is a simple kind of weighted sum of some select features, which results in a score. Of course, there are much more sophisticated models, neural networks, TriNet, and a lot of different techniques here. Actually, this field, as you guys probably know, is getting more and more sophisticated. And then eventually, the score gets as an input to the strategy. And strategy is potentially a simple rule, which takes a score, maybe a couple of other variables, and decides whether decline or queue or challenge or let it pass. And the strategy itself can again be developed in the rule engine, and it depends on, let's say, again, business appetite. So for example, let's say a company enters a new market and has an appetite for gaining market share, then they say, well guys, we have money set aside, we have appetite for high risk, let's our strategy be permissive and let us, pass. If otherwise we would have declined this transaction in this new market, we want to let it pass. So I want to go back and talk a little more about the feature extraction. So again, example talks the best. So let's say, so this is not an example yet. This is just descriptive what feature extraction is. There are many, as you can imagine, there are multiple different types of features, and they reflect certain aspects of account or transaction or historical data. And it can be things such as velocity, for example, like in the example with the random deposit and bank random deposit. Typically, you would see that there is one single bank account is getting 100,000 deposits, right? So it's typical velocity feature would have reflect that anomaly. So this is an example. So let's take an email address. So some people look at email address, and this is just any email address is like another. But if you take an email address as let's say raw data, you can actually build some pretty interesting features on the top of it, which might potentially be predictive of behavior which you are trying to predict. So let's say user ID. So in user ID, you can for example look whether the user ID is machine generated or is human written. Well, it's a guess, right? You can count number of vowels, digits. It's again numeric extraction of some numeric characteristic of a given data. You can look at the consistency with the user ID and other information you have about the user. For example, the name. Domain can again show different trust level. So like Gmail, Yahoo, the freely available domains, of course their trust level is less than if it's a corporate email domain. And there are some email domains like mailinator.com which are obviously fraudulent or one time only usage. So even looking at the domain, you can have a pretty good system of assessing how much risk is associated with the given domain. And there are some speculative too. For example, age. You can speculate that the person with the email address with AOL is older than the person with the email address with Gmail, right? And again, it's speculative, but it still might add some value. There are companies which scan the web and provide some information about email addresses, how old they are, for example. And that's another big variable, because if the email address was created yesterday, then the chances are there is something fishy behind it compared to if it was created 10 years ago. And internally, obviously, you can use email domain velocity or particular email velocity, how many accounts you have with given domain over time, and it can also tell you certain things. For example, I remember a time when there was a big breach at Yahoo or at Hotmail, and we knew that people potentially use the same password and on email and PayPal. So we were sure that there will be some type of attack on PayPal after the breach happened on Hotmail with the accounts which are Hotmail accounts associated with PayPal. So all things are kind of connected together. The output, as I said, it's a score. And I also mentioned how the score is being interpreted by the strategy. The models typically have to be refreshed because obviously, we are talking about the moving target, we are talking about the other side, which also keeps evolving, and so we need to catch up with them. And so there is whatever infrastructure you build for fraud detection, that infrastructure should allow you relatively painlessly refresh, recalculate these weights, and add more data so that your output is more efficient. And this is a development process. Again, there is the step which is called performance tagging. That means you take the transactions from the past or whatever behavior, let's say logins from the past, and out of these logins which ones were resulted in loss and which ones didn't result in loss. So the ones which result in loss, you want to predict and prevent them in future. So that's what we call performance tagging. Feature extraction, we talked about it. sampling is simulation of these features, and then eventually you deploy and develop and deploy the model, and then once the model is live, obviously you have to monitor it for performance degradation, and then the whole cycle goes from scratch again. Well, at the end of the day, both rules and models coexist, and as I mentioned, first of all, rules also they have the strategy, but also sometimes you just don't have data for the models. Like it happens when you deploy a new product. You deploy a new product, you can only guess what would be ways of abusing the product. So even without data, you cannot build the model. You start from building the rules and deploying it together with that new feature. So rules are still needed. However, obviously models are, as again, I call them as a strategic weapon which you have, and you have to maintain it, and that goes directly to the bottom line of your company. In a sum, and I promise that I will stay on time, ultimately, the best results are yielded when you mix the domain expertise and the data science. I've seen companies which do only data science, and they only go so far. I've seen companies which only do the domain expertise. Again, then it's not scaling as well. But together, they are very powerful. Ultimately, as you figured out, it's not black and white game. You will never have a perfect solution. Especially, and you will never be done. Ultimately, you can never say, "Oh, we got it, it's implemented, let's move on." The system has to be by definition maintained, and whether it's because of new products or whether it's because of new MOs or fraudsters. But ultimately, even if you never get there, you are never done. You're already successful if you can run faster than your neighbor. Because from fraudsters' perspective, they don't care whom they defraud, because money is money. If you manage to raise the bar and raise the cost for fraud for them high enough, they will switch to your competitors, right? So it's not so bad after all. You can still win the game. It's all ultimately about return on investment. Fraudsters also think in that terms of return on investment. So again, if you raise the cost of committing fraud on your side, they will just go to somebody else. And so that's pretty much it. And if you guys have any questions, I would be happy to answer. Yes, please. You have. Yeah. Yeah. So the question was about the early stage startup, how to avoid fraud. So again, as I mentioned, from fraudster's perspective, it's all return on investment thing, right? So let's say if you put a lock on your door in the house, then it's already first line of defense. Then the person, if other doors are wide open, then people would not come to your house. So you have to build that first line of defense. At least you have some due diligence, at least in the beginning. Now, one thing you can do is build your own, and you don't have to do a rule engine. You can have some no-nonsense rules, even built using your code, or you can use. There are a bunch of companies which do risk as a service, and if you can. And they are pretty cheap. Some of them, like, they give you first 10,000 calls to them free. You can actually incorporate the calls to these companies, and I can give you a couple of names, and they do some basic fraud detection for you, so that you can focus on your main business, and they will cover the basis for you. But depending on, of course, what business you have in, ultimately, if you are, for example, in payments business, I would advise you to still build in-house that expertise, because it's a core expertise. If you are in some other business, maybe e-commerce, for example, you want to focus on something else, then you can use risk as a service companies. Any other question? Yes?
You were fast, man.
Well,
Hi.
I promised.
What would you advise for a company which is maybe not such as big as PayPal or eBay, but what you will consider as a first step for a smaller company, which is, some kind of related to the business, for example, for money transfers and stuff like that, but just the first steps that companies should take to address such as risks?
So I mean, if we're talking about the small company, which I mean, if you are moving money, it's payment, or even e-commerce. If you are e-commerce and you are selling things which are of high value, such as electronics or jewelry, then I would advise definitely to think about fraud from the beginning instead of later on realizing the problem, right? And as I mentioned, you can do some basic stuff yourself, or you can use others like risk as a service companies, such as Signified or Sif Science, the Count, K-O-N-T. There are a bunch of companies which allow you to call them, their APIs, and in real time they give you some kind of score about how risky that is. So if you want to get it out of the way, don't think about it in the beginning while you are developing your product, then that would make sense. Or ultimately you can of course go without fraud detection, but as soon as you start seeing some chargebacks coming your way, some stolen credit cards, for example, you start actually bearing losses, then you have to move fast. You have to really move fast to either use these products or develop some kind of rule engine-based solution yourself.
Another question? No one? There we go. Titus, go for it. He's a lawyer, be careful.
And an entrepreneur and an investor. So really interesting story about fraud detection, but I wanted to ask you a personal question. How does it feel to be back in Poland after so many years and seeing, being academic in the IT sector, working in the Valley, and now being here and looking at all of the startups that have started? Yeah.
Well, thank you. I left Poland 15 years ago, and but I always considered obviously Poland as my second motherland, and I'm saying in America, I'm saying, well, I'm Polish Armenian. I've been to, I managed to be every several years back in Poland to Krakow, not to Warsaw. So last time I was in Krakow last year, for example. So, and of course I am amazed, and I can tell also as a person who is both insider and outsider how Poland's image is changing, how it evolved in the last 15 years. I remember when I just came to US in 2000, I was offended because I went to a Polish festival. There was a Polish festival in Silicon Valley, and it was presenting Poland as if it was still, back in the PRL. And I was like, guys, please, these are pictures with, maluchs, and even Krakow doesn't look like this anymore, and you guys live in the past. But now it's completely different, right? And especially in tech scene, I can see some success stories such as Brainly being known in Silicon Valley, and I'm really amazed by, overall, the atmosphere at Bitspiration. And I'm really glad that I can say that really that there is huge difference, and I'm looking forward to actually working with you guys. If you have any questions later on, if I can help in any ways, let me know, because again, as I said, I always think about Poland, and I have Polish friends actually in Silicon Valley too, of course. Thanks to that, I still speak Polish, yeah.
So let me translate that. He's looking for someone to hire him to move back to Poland. Or something like that.
So that I can come over and over again, yes.
Okay, well, we're out of time. So, thank you very much for your fantastic talk. Guys, thank you very much. Big round of applause.
Thank you.